Our next unit is law of sines and cosines. Hopefully you're familiar with these from Algebra 2. First, we're going to start by taking a look at law of sines. One thing to remember for both of these laws is that they work for any triangle, not just right triangles. So we're used to using trig with right triangles. These two laws work for any type of triangle. Another thing to keep in mind is that when we name an angle, the side opposite that angle has the same name. We just use a lowercase letter for the side and a capital letter for the angle. There's two different ways to look at law of sines. Sine of the angle over the side opposite. So looking at our first ratio, we have sine of angle A over side A, and that will equal that ratio for any of the other angles. So for law of sines, you really pick two of the ratios to use. You do not need to use all three of them. This law you want to use if you're solving for an angle. It's easier if your variable is in the numerator to solve for it than if it's in the denominator. So the other version is if the ratio is flipped upside down. You can have the side over the sine of the opposite angle. So you'll want to use this version if you're solving for a side. Both versions get you the same answer. It's exactly the same law. The only difference is how quickly you can solve. We're also going to be using an area of a triangle formula that's different than what you're used to. So I know you're all familiar with the 1/2 base times height formula for a triangle. Now we can use sines as well. So the thing to keep in mind is that if you know two sides and the angle in between them, so basically the angle that's formed by the two sides, then you can use these area formulas to find the area of the triangle. The next piece of information that's important to keep in mind is what the word solve means when we're talking about a triangle. If you are asked to solve a triangle, you're being asked to find all of the missing information about that triangle. So first of all, the easiest piece of information to find is that missing angle B. We know there's 180 degrees in a triangle. We already have 89 degrees taken up, so that would give us 91 degrees left for angle B. Next, we can use our law of sines to solve for the other two missing sides. Since we're missing a side, I'm going to use that second version. Remember, side B is opposite angle B, and side C is opposite angle C. So we're going to solve for B first. It would be B over the sine of angle B, which is 91 degrees. And that will equal the ratio of any other side and its angle opposite. Well, we know A, side A, and angle A. So that's the one we want to use. We don't want two variables in one equation, so we're not going to put C in there. So to solve for B, all we need to do is multiply both sides by the sine of 91 and then punch this in our calculator, making sure that we are in degree mode because our angles are in degrees. Remember, we always round to the nearest thousandth. So in this case, I get about 31.110 when I round to the nearest thousandth. Type this in your calculator. Look at what the number is that's sitting there and how I rounded. Some of you guys are just cutting it off after 3 decimal places, and that is not accurate. So we've got to get our rounding down. Next, we need to solve for side C. So I'm going to do the same thing. It's a side, so I'm going to put that on the top, and then the sine of angle C. And I'm going to use that A again because B we rounded, so we'll get a more accurate answer if we use the side that we know. Again, multiplying both sides by the sine of 49. And punching this into our calculator. And for this one, we get about 20.482 for the length of side C. This example, we're just solving for the measure of angle C. Since that's our variable is an angle, I'm going to go with sine of C over side C. And then we know angle A and side A, so sine of 32 degrees over 5. This time to solve, I'll multiply both sides by 8. That gives me sine of C, so I will have one more step to get C by itself. At this point, for most of you, I do recommend going ahead and punching this in your calculator and getting a decimal, and then we can take the sine inverse. But if you take sine inverse of the answer, there should be an option on your calculator to put the answer in there. Then you'll have less rounding error than if you round it when you put it into the sine inverse. So for my sine of C, I got approximately 0.848, again rounding to the nearest thousandth. Type this into your calculator, take a look at how I rounded instead of just cutting off the numbers. So now when I do sine inverse, I'm not going to put 0.848 in, I'm going to hit the second and then the answer key so that the calculator does less rounding and I get a more accurate angle measure for C. If you need me to show you how to do this on your calculator when we're in class, please make sure you ask. Typically, I have you round to the nearest tenth. In this case, we got 57.98 degrees. So if we were rounding to the nearest tenth of a degree, that would actually give us 58.0 degrees. If you don't put that 0.0 in there, it says that you rounded to the nearest whole degree. I'm also okay with keeping more decimal places than are needed, and that way you'll for sure have the correct accuracy for your answer. And finally, we're going to take a look at those new area formulas. As long as you have two sides that meet together to form the angle that you know, you can find the area using 1/2, multiply the sides together, and then sine of that angle that's in between them. So this would give us an area of 6.252 square units. For area, I would always like you to throw the units on there. If the units are given, of course, you'll use those instead. One last example, we need to find the area of this triangle. If you notice, the two sides that we know do not form an angle measure that we know. So we need to solve for the angle measure first. Of course, 180 degrees in a triangle. We have a total of 120 degrees taken up already, so that leaves us with 60 degrees for angle X. And then we can set up our area formula, 1/2 times the two sides that we know, times the sine of the angle in between them. So this gives us an area of about 6,900.490, and this time we did have units, so square meters.